Still on vector calculus, vector analysis. In this video, we're going to talk about the curl of a vector function. Now, the curl operation acts on a vector and produce another vector. Remember, for the gradient of a scalar field, the grad operator will act on a scalar and produce a vector. The divergence operation, which is this, will act on a vector and produce a scalar. But for this operation that we're talking about here, the curl operator will act on a vector and produce another vector. So this one will act on a scalar to produce a what? A vector. This will act on a vector and produce a scalar. But this will act on a vector and produce another what? Vector. So this is it. Now, I have a vector. I have a vector A sub xi plus A sub yj plus A sub zk. The curl of A, which is this, del cross A. Actually, a cross product is involved in this operation. Okay, it is equal to this. I into partial x plus j into partial y plus k into partial z cross, what's A? This vector, axi plus ayj plus azk. So cross product is involved in this operation. So remember the way to determine the cross product of two vectors. This is it. The determinant is involved. Okay. So we have the unit vectors I, j, and k. So here we have partial x, partial x. Here we have ax. Here we have partial y. And here we have what? Ay. Here we have partial z. And here we have what? Az. So I have a video for the cross product of vectors. So you can watch to understand in details what I'm doing here. Okay, this is actually cross product of these two vectors. So let's proceed. So what would that be? Let's take the determinant. So we take I. If we eliminate this column of I and eliminate this row, we have this left. This, and this. In this case now, we are considering each of these, partial x, partial y, partial z, as operators, not as multipliers. Okay? So, eliminate this column, eliminate this row. We have this times this, alright, minus this times this. Okay, so we eliminate this first row and this first column, then we'll do this kind of multiplication. So this times this, that will be the partial derivative with respect to y of az. That's this times this, okay, minus this times this, okay, which is the partial derivative with respect to z of ay. Partial z, ay. Minus j, this is the j, okay. For determinant of a 3 by 3 matrix, this I, the first element here has a plus, minus, a plus. So plus, minus, plus, minus, plus, minus, plus, minus, plus. So j here has a minus. That's why it is minus here. So eliminate this column of j, eliminate this column, eliminate this row, okay. We'll be having this, and this. This, and this. So we take this times this, minus this times this. You get it? Multiply this, minus, multiply this. So because we are taking it as, that's because we are taking these now as operators and not as multipliers, this will now be the partial derivative of az with respect to x minus the partial derivative of ax with respect to what? To z. So we have the partial derivative of az with respect to x, partial x of az minus this times this. That will be the partial derivative of ax with respect to z, partial z of ax. Then we'll come here plus k. Okay, eliminate this column of k, eliminate this row of k. What's left? This, and this. Okay, so this into this minus this into this. So this into this, we have partial x of ay minus partial y of ax. So we have I into the partial derivative of az with respect to y minus the partial derivative of ay with respect to z. Okay, if we send this minus into this bracket, we have plus j. This become plus and this become minus. So we're having the partial derivative of ax with respect to z minus the partial derivative of az with respect to x. Then plus k, okay, plus k. We have the partial derivative of ay with respect to x minus the partial derivative of ax with respect to y. So this gives the curl of this vector a. So we can either choose to determine the curl of a vector function by directly applying the formula, okay, or we just start the process from here, whichever one we choose, okay. So we are still going to obtain the same answer. If we have a vector b that is equal to yzi plus 3xzj plus 2xyk, we have to determine del cross b, which is the curl of b, okay, at this point 1, 2, 1. Solution. Okay, let's solve it. We have the vector b equal to yzi minus 3xzj plus 2xyk. Okay, so the curl of vector b, which is del cross b, is equal to I partial x plus j partial y plus k partial z cross this. That will be yzi minus 3xzj plus 2xyk. So let's evaluate the cross product. Okay, so we have ijk. So this is partial x for I, and we have yz here. Yeah, this is the coefficient of I here, okay, and this is the coefficient of I here, which is this. So for j, it is partial y here, and here it is minus 3xz. For k, it is partial z. For k here, it is 2xy. Evaluating these determinants, we have I into eliminate this column, eliminate this row. So we now have this, okay, this, and this, all right? So this into this, we have the partial derivative of 2xy with respect to y. That's this times this minus this times this. That's the partial derivative of minus 3xz with respect to z. That's this times this. Okay. minus, I told you j has a minus. So minus j into, eliminate this column of j, eliminate this row. So we now have this, and this. So this into this minus this into this. So we have partial x, that's 2xy, minus this into this, that's partial z into what? Yz. Plus k. K has a plus. So eliminate this column of k, eliminate this row of k. We have this, and this. So this times this minus this times this. That will be partial x of this into this minus 3xz minus 3xz minus this into this. And what would that be? The partial derivative with respect to y of yz. So this is it. Let's evaluate this. I into, let's differentiate this with respect to y, keeping x constant. So if we keep 2x as a constant, differentiate y with respect to y, that's 1. 1 times 2x, that's 2x. Okay, so we have, okay, let me just say 2x into 1. 2x is the constant. Okay, differentiate y with respect to y, that's 1. Minus, actually, this minus will intersect to give a plus. Okay, but let's leave it this way. Differentiate minus 3xz with respect to z, keeping other variables as constant. So if we keep minus 3x as a constant, differentiate z with respect to z, that's 1. So minus 3 times 1. Then we have minus j, okay, minus j. Differentiate this with respect to x, keeping y as a constant. Okay, so if we keep 2y as a constant, differentiate x with respect to x, that's 1, minus, differentiating this with respect to z means that we have to keep y as a constant. Then differentiate z with respect to z, that's 1. Plus k, so differentiate minus 3xz with respect to x. It means we have to keep minus 3z as a constant. Then differentiate x with respect to x, that's 1, minus, differentiate this with respect to y. We have to keep z as a constant. Then differentiate y with respect to y, that's 1. And this is equal to I into 2x plus 3x. Minus is a plus. So 2x plus 3x, that's 5x actually. Alright. So we have minus j into, this is 2y minus y. And 2y minus y is y. Plus k into, this is minus 3z minus z. So minus 3z minus z is minus 4z. So we have 5xi minus yj minus 4zk. So this is the function for the curl of B. At the point 1, 2, 1, the curl of B is this. X is 1, y is 2, z is 1. So we have 5 times 1 into I minus y is 2, 2j, z is 1, 4 into 1 times k. So this is 5i minus 2j minus 4k. So this is the curl of vector B. So this is how to determine the curl of a vector function. Support by subscribing to this channel, like and share this video to your friends and to your classmates.